Today we start our unit on motion, and in this course, Advanced Maths, we're only looking at motion in one direction. So that really means that you can think about it as motion along a horizontal or a vertical line. Now examples of this, well perhaps we have a number line and we have some object that's moving along it one way or another. Perhaps we have a ball that we're throwing up, straight up in the air and it's coming straight down. Or perhaps we're dropping something and it's going straight down and it's going to bounce and come up again. But make sure in this whole unit that you're only thinking of the motion being in one direction. It's not moving around in 3 dimensions or even in 2, it's literally just in 1. So we've got 4 words here that we need to define. Displacement, distance, and today we're looking at average velocity and average speed. In the next lesson we'll look at instantaneous velocity at any one moment and instantaneous speed at any one moment. But for today we're looking at the averages of these, which is an easier concept I think, and it doesn't require calculus, it just requires careful reading of graphs. Now I've broken these 4 words into a table here because they've got some similarities. These 2 are descriptions of the position of something, and we're going to call that position x. So if we had something moving along a number line, then if it had moved along and was sitting at 2 on the number line, then we'd say x was 2. If it then moved along to 3, we'd say x is 3. That's obviously made a movement there. It's gone forward 1. So if you're looking at the displacement of something, this includes the direction. Clearly moving from 2 to 3 is going up 1, so the displacement is actually positive. Now how can I tell? Well, I've got a formula here for it. It says take the second place that you're in, x2, and subtract the first place. All right, 3 minus 2 equals 1, positive 1. So clearly the displacement there was positive. I moved up the number line. I can also move down the number line. So you'll notice that both of these terms here, they include direction, which can be positive or negative, or it can be 0. So if I was to go from position 3 on the number line down to position 2, then the place I've finished, or in other words, the second place that I was in, would be 2. And 2 minus 3 would be minus 1, which makes sense. The displacement is minus 1 because I've gone backwards. If we're talking about something going up and down, a displacement that's negative would mean that it's dropped, and a displacement that's positive would mean that it's gone up. Now, how is that different from distance? Well, distance says I don't care what the direction is, I just want to know how far you went. So distance is much simpler. It says that going from 2 to 3, that's a hop of 1, and going from 3 to 2, that's also a hop of 1. We don't care which way it is, you've gone 1 unit. So you can see here it's the same idea, but it's got absolute value brackets around it, because we don't care if it's minus 1, we've just gone 1 unit if we've moved 1 place on a number line. Similarly, if you've thrown a ball 5 metres in the air, or you've dropped a ball 5 metres towards the ground from standing on a building or something, the distance travelled is the same, whereas displacement will take into account whether you've gone up or down, left or right, depending on if you're moving in a horizontal or vertical plane. So those are quite straightforward, I think, but this word is probably the one that could be new to you, and this one is the more logical one you've used in the past. And they both describe where something is, which we're calling x. Now these 2 are both describing how the thing has travelled, how fast has it gone. So I've got 2 words for being fast. We have velocity and we have speed. Now velocity, like displacement, is the one that takes into account the direction. So if something's going up really fast, then the velocity will be positive. But if it's actually going downwards, then it will be negative. Now, why is this? Well, it's because the formula says, let's just look at the change in displacement. And here, this little arrow, triangle, means change in. So the change in the displacement over the change in time gives you the average velocity. So that means if the displacement was negative, like when we went from 3 on the number line down to 2, then your velocity will also be negative. It doesn't mean you're slowing down so much, it means that you're going backwards. Or if it's in a vertical plane, it means you're going down. Speed is different, it doesn't care about the direction. It just says, what's the change in your distance compared to the change in your time? So whatever the distance travelled is, how long it took, you turn that into a fraction. So let's get this down in our books. This will make a lot more sense once we look at a simple example and we can look at how we'd calculate any of these things really quite simply.